Hi, my name is David. Today we're going to do number 1859, sorting the sentence on LeetCode, and we'll be solving it in JavaScript. So we want to sort the sentence, and it takes an S, which is a string that represents a sentence. And we can see here is sentence this A. And it wants us to return this is a sentence. And this number indicates that this is the first word. The second one is the second word, third one, and fourth one, fourth word. And in this example, this is the first word. So me goes first. We look for the 2. That goes second. And goes third. And I goes fourth. There's also that there's like no trailing or leading spaces that can throw this off. And that there's can only be numbers 1 to 9. And yeah, there's going to be 1 to 9 words inside of it. So how we can solve this is that we can first split it into an array by the space. So create word array by splitting S. So that will give us this word. And now this, we can use it as the indicator of the index value. So we can get that value inside of it. So we'll have to loop through this. So we're going to loop through this new array we created. And inside of this, we're going to get extract. It's always going to be at the end. So get index value by slicing. And I'll show you what I mean by slicing. Slicing the current word by 1 by -1, then -1, because we want a 0 index and this starts off at 1. So JavaScript has a slice, and we can see here basically it can either just take a start or a start and end. So here we want the last one, so we can start it at the very last element. And here, just to point out, it can take negative numbers. So a negative index can be used, indicating an offset from the end of the sequence. So it is used to indicate the last one. So that's why we slice it by -1. And we're starting it, and we don't have an end. There's no need to end because we're getting it the last one. And whatever's left is nothing's there. So the end optional. Okay, so we slice that and get the index. Now, actually, there's a step before this. So we can create this is the array we will return. So ordered sentence. So this is what we're going to do. And then we're going to update this index with the proper ones. So we were able to get this. So we're looking at this word now. We get this. So we're able to get this index value. And now it's 1. So now we can update the index of 1 of order sentence with this current word. And we already extracted as we loop through. So update ordered sentence with that index to current word slice, and we don't want to include this last word. So we begin. We want to begin at 0 and end with the -1, and it says the end is up to but not including. So that's how it will include it. And lastly, we just return array. Great. So here, let's first split it. So const word array equals s dot split, and we're going to split it by empty space. So let me console it for you. Sorry, I didn't console log it. You see here, this is the current word. Now we split it. Now we're going to loop through here. There's 0 I is less than word array dot length I plus plus. And now here we want to get this value, so we can do const index. So we can do idx equals word array dot I, the current one. And now we want to dot slice -1. And let me console log it so you can see. You see here, this is the 2, the 4, 1, and 3. So now we have that. Now we can update, now we can create this order sentence array. So const ordered sentence equals an empty array. And now we're going to update that. So we have index, and then we have to minus by 1 because we want to order the 0 index order. So we can see here now, so this one will be the first word and so forth. So now we can update order sentence by this index. And we set it equal to this current word that we're looking at. And we want to slice it again, but this time from 0 to -1. And now we just return ordered sentence. And now, lastly, forgot we have to put it as a string, joined as a string. So we do dot join by the empty space. Great, we got it. So now let's remove this. So the time and space complexity of it, it's kind of tricky. I'm actually not too 100% sure on this because it's a lot of it's string manipulation as well with all the slice and joining. But I want to say for the time, we're iterating through S here, and then we're iterating through it again, the array form, and then we're iterating through that word to get the last one, and so forth. And I'm thinking, and then we have to join again. So this is gonna round. It's gonna do a lot of O of n's, but it's gonna be O of n multiple times, but it's gonna round down to O of n. And now the space complexity. This is creating an O of n space. This is creating space that we have an array that's going to take up the same amount of space. This is slicing it so it creates new words. And this one's creating new words as well, but it should be the same. It should, and then this is joining it together. So it's also going to round to O of n, I believe. So O of n for time and space, because these are constant depending on the, so these are depends on the length here, and however long these words are is going to be the same amount of steps. It's not going to be exponential to it. So that's how I solved this problem. Thank you so much.